Hello and good morning, everybody. Balkrishna, I'm talking about Advanced Frugal Innovations. Associate Professor, Department of Engineering Design, IIT Madras. And thanks to the efforts at LUH and Ministry of External Affairs, they awarded ICCR Visiting Chair Professor. And this is typically given for Indian studies. And Government of India is also slowly identifying frugal engineering, frugal innovations with the India connection. And so this was given partly based on that. And I think I have to also go back and probably brief them up how this has helped from a frugal engineering perspective for India. So first of all, there are many people to thank, many institutes to thank. Of course, Ministry of External Affairs, Government of India, and they made this possible through what is called the Indian Council for Cultural Relations, ICCR. It's an arm of MEA, and this is where they do a lot of this cultural exchange with different countries. And they set up these visiting chairs all over the world, and I think LUH has MOU with ICCR which has made this possible. So thanks to Ministry of External Affairs through ICCR. Grateful to IIT Madras, obviously. I think the last 10 plus years at IIT Madras, departments of mechanical and more engineering design. A lot of this research was possible because of a very conducive atmosphere. Also the freedom given to kind of pursue these kinds of areas which are maybe high risk but also have a lot of potential. And also nice colleagues, which makes the campus even better, and nice discussions and whatnot, infrastructure, all that has gone a lot. I think there are not enough words to thank IIT Madras for providing a lot of these facilities. Leibniz University, Hannover, very grateful to them, especially Professor Ingo Leifner. I think he contacted me initially while in India, I think more than before the pandemic. We go back, I think, at least 3 years with this idea of frugal innovations from an engineering perspective. And he, working with Dr. Balaramani, who's not here right now, made this chair possible. Balaramani has put a lot of effort, based on what Professor Ingo Leifner has told me. Very thankful to him for that too. Special thanks to him to make this position possible. And thanks to LUH for the patience shown, because I was supposed to have come in 2020, but it was bureaucracy plus COVID. And and bureaucracy on all kinds of sides. I'm not blaming anybody. And you can't, and some of these things, it's also an official position, so you need to get political clearance and a lot of other things, so these things take time. So I'm glad we are here. It was late, but not never. And finally got a chance to come to LUH and meet all of you. And a special thanks to our guests, Professor Peter Noringa and Professor Alexander Brain, for taking the time to come here, despite their hectic schedule, and making time available for this workshop so we can hear your, valuable opinions. Also thankful to Dr. Nivedita Agarwal and Dr. Rajneesh Tiwari for attending this event. All very important, I would say, participants in frugal innovation from different aspects. And today, look forward to kind of presenting some ideas and also hearing to your ideas and see how we can come at some kind of a common consensus, and whether we agree and all of that. Hopefully I've not forgotten anybody to thank. If I have, I'm very sorry about that. I think there are a lot of people to thank. So thanks to everybody in general, and thanks to our students who have made it here today, Julian and Leonard, who have worked behind the scenes to make this event possible with a lot of, I think they came today early morning to set this thing up and whatnot. So and thanks also to Lucas for coming here and the engineering team, which we will be meeting tomorrow. So with hopefully a brief kind of thanks to everybody, get started today. I'll start first with Europe's heat wave. Right? We are quite, we experienced this recently, at least when I came here in the months of June initially. The weather was kind of unusually warm, and I was also told that this is not usually the case. I mean, there has been like more variability than usual. And even UK, I think, went through a very kind of excessive heat stress. And many parts of Europe also suffered, not just UK. And this is a graph taken from The Economist. It says that basically very strong heat stress feels like 38 to 46 degrees Celsius. And this is not just Europe, but world over you are seeing these kinds of temperature swings. Very high temperatures, also maybe getting cold. I'm also told that it is kind of unusually cold for this time of the year in Germany. Hopefully I'm right. The point I'm telling you these things is, we were all tired with the pandemic. I think about 2+ years gone in the pandemic without anybody's fault. But there is a bigger crisis lurking. Not lurking, it's actually happening. Okay, it's called climate change. It has started quite some time back. I think since the industrial revolution started, probably. And it's a silent killer. And this is an irreversible phenomenon. We are already into it. And the only thing we can do now is to adapt, mitigate, and also adapt to kind of live under these new conditions. So here are some of the effects of climate change, right? First thing was the heat wave in Europe. We also experienced or heard about and read about the floods in Pakistan, right? Which is unusually very heavy monsoons. And increasingly, there is something called attribution science, which is being used world over to tease out the effect of climate change in all these events, in all these catastrophes, okay? So climate change is a different beast, and normal weather prediction is quite nonlinear, and climate change goes beyond that. It's kind of a stochastic process that we call. It's kind of, you put a kind of a probability or a chance of this happening. Very difficult to predict. But over the past decades, the prediction has gotten better. The uncertainties are kind of reducing, and scientists are able to tell you, researchers are able to tell you that yes, this is happening, high probability due to climate change. So all these events have a hand of climate change happening in the background. Okay, that's just one of the crises we are facing. So we all know this, right? Mont Blanc. And the interesting thing is that the mayor there, I think, decided to take 15,000 euros deposit for people coming to Mont Blanc during this summer because of the unusual heat. So a lot of the glaciers got kind of, had some erratic movements, the snow melting and whatnot. So they needed this deposit for insurance, and also kind of if you're stuck, something unforeseen happens to help you out. So, and this was not done in the past. So these are all like, very kind of new novel solutions, okay, to kind of cope with the weather which is changing erratically. And heat wave exposure, population affected by various risks. Heat wave exposure, water stress, you have risk to power production, crop yield change, habitat degradation. Climate change affects, along multiple aspects, I would say, in the way we are living. And here I'm trying to just bring out some of the ways it is kind of changing planet Earth. There is a chance, okay, that you might lose Greenland, or for that matter, the ice sheets in Arctic and Antarctic, which is like a very extreme scenario, because as we are talking, a lot of this ice is thawing slowly, okay, and because you have to keep the volume of the ocean has to remain constant, all that water enters the ocean and the sea level rises. So the worst case scenario, they're saying about 6 meters of sea level change, okay, possibility, okay, extreme event. Again, these are not like, you always have a chance associated with it, only the future will tell us, and hopefully we don't pass through it. But yes, these things are happening. Greenland is kind of losing its ice, and so is Antarctica and Arctic. In fact, people are very happy that, the Arctic is opening up for new, sea lanes, right, to kind of ply that trade. And countries are actually staking claims to do a lot of resource activity there, in drilling for all kinds of, very valuable resources in the Arctic. But, the sad thing is, this has been made possible because of climate change, and the Arctic and the Antarctic are there for a reason, And it's very interesting because Earth is in what is called a Goldilocks spot. We are neither too far away from the sun or nor too close. That is why life has been made possible here. So any change in those very, kind of sensitive conditions, it's any change there creates a problem. The other thing that you see here is not a geyser, but what we call methane emissions. Okay, that's the other very potent greenhouse gas. There are many greenhouse gases we typically talk about now. Carbon dioxide is very popular, but you also have methane, then sulfur dioxide. There are also nitrous oxides coming from aviation. So all these things are slowly taking their toll. This is again because the temperatures, average temperature is rising on the surface of the earth and also the surface of the ocean. There is more, to put it crudely, evaporation. So this also leads to more intense storms. Storms which are not maybe, intense storms are becoming frequent, and they also move slow, right? So in the process, they dump a lot of rainwater through precipitation, storm surges and whatnot. And I think currently, as I'm talking to you, there is a hurricane Ian, which is barreling towards the coast of Florida. And many of the emerging markets are also bearing the brunt. Like we routinely in India have these very intense cyclones, and even monsoon dumps a lot of rain nowadays, which is more than what is expected in India. Also, the sea, ice is receding. This is somewhere in the Arctic. It looks very nice, very picturesque. You see this person nicely sledging through this ice receded part, which looks like a nice shallow lake. But the truth is, you should have seen a lot of ice there. So they are good, but also bad. There is also faster erosion with the glaciers and also mountains in general. And I think sometime back I read that the ecosystems that you see around you are not what they were, even maybe if you go about some millennia back. So these have all changed with time. And currently we take it for granted how much is changing around us. Okay, we're also going through a big mass extinction. I don't know how many realize that, along with climate change. The Himalayas are in trouble, mighty Himalayas. Okay, so it's very confusing. Sometimes you see like a lot of precipitation, heavy rainfall, what we call cloudbursts. And you might have heard about many of the catastrophic incidents that happened in a state of Uttarakhand. Like many of these. Sometime back 2013, I think we had like a little tsunami at around 12 to 13,000 feet. Okay, a very important locality in the Himalayas where the lake just burst open. We had excessive rainfall there. And there is also drought, so which is very hard to reconcile. You have drought and you also have a lot of precipitation. This is not just happening in the Himalayas, but also many parts of the world now. We are seeing drought and excessive precipitation at the same time. The Himalayas are also rightfully called the third pole in the world. Okay, I don't know how many know this. You have the North Pole, South Pole, and the Himalayas are called the third pole because of the sheer amount of ice that they carry. Okay, after the two poles. So yes, and they feed a lot of rivers. So there is a third pole, the Himalayas. Most of the Indian subcontinent, many of the rivers are fed by these glaciers. So it's very important because climate change is slowly making these glaciers recede, and that is not good news. These are glaciers in Peruvian Andes, and you can see the thing receding. And it's very interesting now because we have come to a point where, thanks to the digital age, a lot of new information is available to us. And a lot of military information has been declassified by the US government and other governments, and they're using that to compare the maps of the same region or satellite photographs, and you can clearly see the glaciers receding and the change that has been wrought by climate change. Any idea what this is? Any of you can take a guess? Yeah, there is a big crack there. So this is actually the permafrost in Alaska, right? So beneath all this ice, you have the permafrost, and the ice has basically thawed. It has gone, and the permafrost has thawed, and you have this nice big crack now. The problem with this is there are a lot of methane deposits right under that structure there, and even under the oceans. So with the gradual warming, a lot of the methane is getting released. And now researchers are saying that methane emissions can be sort of controlled in the short term. Okay, it is easier to control, and that will take a kind of a decent portion of your global warming away. But the main beast is of course the carbon emissions. They take a long time. Once they settle in the atmosphere, it takes like about half a millennium for it to go away. Okay, so this is now like what we call in engineering a positive feedback. So climate change is happening, it is making things happen on Earth, and that is again feeding into that, and this is getting more and more with time. Alaska. Again, the oceans are taking a big hit. Oceans are also a sink, for the carbon that is emitted on this planet. One of the major sinks. So the water is getting warmed up, it is also turning acidic, and not to mention sea levels are rising. Okay, so you have sea ice loss, rising waters, warming waters, pollution, shifting currents. And this, I believe, is a map of actually how acidic the waters are getting thanks to the CO2. This is affecting the coral reefs around the world. And a lot of these things are very intricately linked. You damage your coral reefs, that is like the first barrier against storms and whatnot, right? And you need that. You also have a very healthy ecosystem there. And not to mention, you have a complete marine, ecosystem dependent on it. And a lot of the world still lives on, seafood, right? I think, so this is very important, the way it affects us. Ecosystem services, I think, are getting affected due to climate change, and it has affected our living on this planet in a big way. There are more allergies. I don't know how many of you have noticed this, but they're documenting this. More drier seasons, so there is more pollen and more respiratory-based particles in the air, and it is leading to more of these respiratory diseases like asthma and whatnot. Also affects your cardiovascular health. So this is also, climate change is causing all of these in different ways. You never realized this. Animals are being shifted. Okay, there is also, like I told you, a mass extinction going on, and thanks to climate change, a lot of the habitats are not becoming livable for many of these species, so they have to be transferred to other places just to keep this thing alive. And we also need all of these creatures with us because, like I told you, ecosystem services make our living on this planet better. Okay, so we can't lose these creatures. Again, I'm told that, very sad plight for the polar bears. They are seen sometimes in the main cities of Canada, I'm told, where they're not supposed to be because of the receding sea ice and also loss of prey. That is the other problem too. This is a lot of grazing activity in Brazil, and usually the Amazon is considered lungs of this planet, right? And a lot of that is also getting lost out due to deforestation. And this affects us significantly because land-based carbon sinks, the tropical rainforests are very important. So all in all, overall, and this will be my last slide from a climate change perspective, there is climate change happening. You also have a population explosion, a mass extinction, and other planetary crises related to these, and they're interacting with each other. And this is kind of, we can't take things for granted from here onwards, the way we are living, okay? And since the Industrial Revolution, we have gotten a lot of nice things, which have made our lifestyles better. It's lifted our living standards, but that has also taken a toll on the planet. But what this means is, at least what I think, is that technology is somehow created this menace, and it is technology that has to be used to kind of control it. And the other alternative is to be abstemious, right? To go into a very hermit-like living conditions, right? Not expecting much and just living on nature, and which I think is not doable now. Okay, the majority who have gotten used to these kinds of comforts, you want to live with it. So I think technology could be used to help us out, to adapt and also mitigate this crisis at the same time. And like I told you, this is an irreversible phenomenon. We are into it. There is no way of coming out of it. The only thing we can do now is to mitigate from here onwards and try to adapt to a changing environment around us. Now, after this, I'm going to start with something totally different, okay? Frugal innovations. And I'll tell you how these two are linked together. So I'll first start with India's contribution to science. The reason I'm doing this is just to tell you that before coming here, when I came to know about Professor Ingo, that he works with Leibniz University, it got me thinking. Leibniz, it's the same Leibniz who was responsible for the calculus that we engineers take for granted, okay? And we have this derivative symbol which is dy by dx. I won't go into the details of that, but thanks to Leibniz, we are now following that terminology the world over. And Newton had his particular terminology, but that is not used. It was more complicated than what Leibniz suggested, and both of them came up with the same idea around the same time. They were also rivals, okay? So it makes very interesting reading. So if you have some time, you should probably look into it. But what is not known, there is also this Indian School of Mathematics from Kerala, and there's one person in particular called Madhava of the Kerala School of Mathematics, who got into this independently, into integral and differential calculus. And there are some infinite series that are named after Madhava, along with the other European mathematicians that were involved at that point in time. And it has been told, at least according to modern research, that Madhava predated both Leibniz and Newton. So now they're slowly giving the credit to three of them. You have Newton, you have Leibniz, and you also have Madhava from India, the Kerala School of Mathematics. India has been instrumental in giving the zero, right, to the world, because I think the Greeks found it difficult to contemplate about something which is something for nothing. And also they had a problem with rationalizing about irrational numbers. And you'll be surprised that the Sulabha Sutras in India, right, where we make this Vedic altars, many of the dimensions have like a square root involved of 2 or 5. And these people knew how to find out a value for that. Okay, this was way before formally it was accepted how to figure out what's the square root of a number. Okay, such as 2 or 5. The spread of Indian numerals from India to the Arabic countries and also to Europe. This is also nicely documented. And here is another slide which basically shows you a history from the world and India, like, from 1500 years before, Christ, and also 2000. And it shows where we are currently. And Madhava is placed right here, around, between 1500 to 2000. So, interesting what he did. And you can see on the other side what the world has done. Parallel developments, but it was not acknowledged in the past. But now researchers are looking into it, and a lot of this thing is getting published. And G.C. Joseph, he has a nice book on Indian mathematicians. So if you have a time, you can look at it. The reason I'm showing this slide is Indians are kind of used to thinking about a lot of abstract problems. So it's also maybe based on our culture. We are made to think in an abstract manner. And this has kind of sometimes helped in, how you think about various problems. And thanks to our also history, over the past 10 centuries, all the, the invasions and whatnot, colonization and whatnot, people have learned to kind of be resourceful. That thinking has helped them and to kind of live probably under scarcer conditions. Now, of course, India is doing better and better, and economically it is turning out to be a force to reckon with. But in the past, right, this thinking has always helped to kind of develop something ingenious, right, with scarcer resources. And this is what leads to frugal innovation. At least that's a connection I see with India, okay? And here is the first humble frugal, what I call a very cheap cappuccino maker. So you have a pressure cooker which has been retrofitted to make cappuccino. And in India, a typical cappuccino will cost you about 200 to 500 rupees, where you have it, but this one will cost you about 5 rupees, okay? Now, the interesting thing here is the person involved doesn't know how this thing works. He has nicely retrofitted it, and it has worked, and he's happy about it, and he's making a good business out of it. So this is how the idea of, I think at least, frugal innovations were born. These are like devices which are low cost, out of scarcer resources, but give decent functionality, okay? And in this case, there is no formal science or engineering that has been applied. And this could be labeled as a grassroots frugal innovation. Okay? So a frugal innovation at a grassroots level. So the only thing missing is a formal application of science and engineering. But other than that, it has the features of a frugal product: low cost, low in resources, maybe simple design, and decent functionality. Another example of this is Mittiku, the earthen refrigerator. This started out as the work of one brilliant entrepreneur from India, the state of Gujarat. And he used the evaporative properties of water together with earthenware to create a fridge, right, or a refrigerator, which can take care of all the local produce, for a very short period of time. So this is affordable for people maybe at the bottom of the pyramid who can't buy a regular refrigerator. But in recent years, this qualifies as a grassroots frugal innovation, but this has now become an advanced. I will soon define what is advanced. It has now evolved to what is called advanced, thanks to formal involvement of, I think, the National Institute of Design in Gujarat and a couple of other scientific organizations who are helping him to get more out of it, to make it better. And now this takes us to what is called advanced frugal innovations, right? So the genesis is from frugal innovation, okay? So low cost, okay? Resources are less, but now I'm formally employing science or engineering to make it possible. Because the frugal innovation idea is so good, there is a lot that can come out of it which can do a lot of good to everybody. But you extract the engineering principle and apply it in virtually any product that you see around you. Okay, you can get a frugal version which makes it better. So an advanced frugal product is low in cost, lesser resources, and it gives good functionality. Okay, so the first example I show here, I will be showing numerous examples now of these so-called advanced frugal innovations, and they will be going in increasing degrees of sophistication. This is a bamboo bicycle, and bamboo, as you know, is a grass family. It grows like 2 to 3 meters a day. It is quite low cost, and what I think not many people know, it has got very good structural properties. If you treat the bamboo well, it can actually be used for construction purposes. And the bamboo bicycle is a very popular concept now around the world. And in fact, IIT Madras, I knew of one of my colleagues who made this with one of his students like a project. And the ride quality is very good, many times better than what you can get with a metallic cycle. Okay, and this was, I think, this project was undertaken by Professor Jeffrey Sachs, Columbia University, with KPMG, and this whole thing was implemented in Ghana. And they had a complete ecosystem built around it. So you have a facility building bamboo cycles and also people using it. So people working for this facility and also using it, for as a mode of transportation. So he kind of built a nice ecosystem around it. So this is a nice example of an advanced frugal product. I'll stop calling it an advanced frugal product from here onwards because every other example is that. So I'll just tell you the features and how this is now appearing in a lot of products that we see around us, although it might not be called by that name. This is a bamboo microscope, okay? And this came from a company in India called Jadu Gyan in Delhi. Brilliant engineering here. So this has very limited, objective power, magnification power, I'm sorry. Maybe just single one. So they started this for use in elementary schools, for teaching lessons in biology. And what later they figured out that this thing was actually used, the bamboo microscope was used for some serious research. And it has been actually mentioned in papers. Okay, so very interesting idea, the bamboo microscope. This is something we've been doing in my lab. It's a human pedal powered water filtration. Okay, so you just throw in the raw water and by pedaling it, you can filter the water. So there is no power going into it. It's a very simple design, but we have done some, you need some good engineering background to build this. It is built around the osmotic pressure of the last filter that you have in your system. So this was done by one of my students. He's now got his PhD from Berkeley. He's now started a startup, I believe, in the US. The concept works. We demonstrated that. We have also patented the idea. We are in the final stages now trying to commercialize this. The frugal washing machine. This is very interesting. So you see a hand cranked washing machine here. And just cranking this thing for about 10 minutes gives you a good wash. The quality is better than the normal, conventional washing machine that you use. Now, the trick here is, to have nice channels here in the drum, the rotary drum. And these channels are kind of very intricate. If you look at the closer section of that, it is hexagonal in shape, and it's got a helical twist to it. And this has been made possible by running simulations on computational fluid dynamics to arrive at this kind of an arrangement. So by having this complex arrangement in the drum, you put the detergent, your clothes, water, you crank it, and within about 10 minutes, you have a very good wash. And I think there's a startup now for this thing called, it's called the Gentle Washer. Okay, and this came sometime back in the ASME, American Society of Mechanical Engineers. They featured this product. Of course, the nano. I thought this was a very brilliant concept. Okay, so it was supposed to be low cost with lesser resources, keep it as simple as possible, but give all the amenities and good quality, not bad at all. And I know that a lot of people still drive nano in India. And the concept, I think, was then used many other places in the world. Probably they got the idea before the nano. I also see the Nissan Leaf and many other cars that are smaller in size and which are based on a similar concept. In Europe now there is a big demand for personal mobility. Okay, going beyond the main roads and into the narrow alleys where such smaller vehicles can make an impact. This is India's contribution to surgery. This is one of the few slides I have as an advanced frugal service. And this is called Narayana Hridayalaya in Bangalore. And they do mass surgeries for cardio diseases. Okay, this is just amazing. Cardio surgery is very intricate, it's very complicated. Okay, and Dr. Devi Seti in India, right, and his team have set up this facility which based their model on Henry Ford's mass production technology for cars. Okay, it might seem odd, but this is a place where you have various doctors who are specialized in what they are doing, and each does his work and takes care of the patient. And believe me that this is also part of so-called medical tourism. A lot of people from the world come out to India to come to many of these places to get operated. It is cost-effective and you get very good care. Many Indian doctors are very talented. So very nice to be to have Narayana Hridayalaya in Bangalore. GE's healthcare. This is very interesting. GE team in China figured out that they were trying to market the ultrasound, which is a very important diagnostic device, medical diagnostic device, for various ailments. And having the conventional variety in China was not helping them much because it was fixed in one place, it was bigger in size, so more cost. And also people in the rural areas and other places had to travel to that place to kind of get diagnosed and use the facilities available there. So all of this involved like a high cost to it. And a lot of people simply avoided, getting an ultrasound done. But then GE had an idea that because there is demand for it, they said, why not make a portable version of it? So all the sophistication of the conventional GE ultrasound was put into a software. And they used a simple probe with a laptop. And the software, I believe, was in the cloud. And they used these two together to reduce the cost and also make it portable and take it to other places. Okay. Now, the beauty of this is it reduced the cost, gave very good service, but at the same time, the model was also exported to other countries other than China. It is being used in many parts of Europe and also US for emergency services and even for normal services, where you want to get an ultrasound done. So I think here are some numbers on it. 2002 price for it was $30,000 to $40,000, and today I think it's about 15 to 100K. The $100,000 I think comes when you add some other features to it, but the basic one costs around $15,000 to about $50,000, and the conventional one is like quite high, $100,000 to about $350,000. Okay, so this is very interesting what GE did, and GE has healthcare devices. I think a research division in India, in Bangalore, the Jack Welch division, and they actually do a lot of research in these low-cost devices. And what they did in India was developing a electrocardiogram. So again, these are the typical conventional ones are clunky devices. They're more expensive, so more higher price involved in trying to get your ECG and use those facilities. So GE thought of making a smaller version, and this is somewhat the size of a desktop calculator, and cost is around $800 to about $1,500. Okay, kind of really a big drop in the price, and also quite popular and good service. I think this is again a slightly different kind of business, Unilever, and this is very interesting what they have done. Unilever has, I think, taken sustainability in all parts of its business. I think their culture is based on sustainability. It's in the research, also the way they work, the way the plants are built, the production model, everything. It's a good case study in kind of adopting sustainability everywhere in your business. And the interesting thing in India is that they were trying to cater to the bottom of the pyramid, and they are very successful in that because they had a strong research division in India for a long time. And this helped them to kind of market the products, same quality products, but maybe in smaller versions, maybe sachets, to give it to them at a lower price. So again, low price, simple, good quality, and affordable to the masses at the bottom of the pyramid. And this also brings out the element of research that you need for these kinds of innovations. Other than the normal engineering, it is also very helpful if you can shine a light of research on it, because these areas are typically interdisciplinary, and you need to see where you can get good ideas to make this workable, make it a frugal version, and get benefits out of it. At Stanford, okay, I've used the word jugaad here. The whole thing started with jugaad, I think, and jugaad has a negative connotation in India. Okay, I think when you say jugaad, it is like some kind of a makeshift arrangement. But the initial frugal ideas, I think, were they got the concepts from jugaad. But frugal is now something more than that. Okay, it has become quite sophisticated, and there is definitely a strong hand of different knowledge areas guiding it to make it better and better. This one in Stanford, TB diagnostics, and this application was in Africa, where again you have a basic center where you have to go and get diagnosed for TB. TB is a big scourge there, right, around the world and mainly in Africa. So to get tested, to get the results, you have to go to a conventional center, again expensive, the cost involved in going there and also making avail of the services there. So Stanford University researchers, what they have done, they devised a very nice dye, a fluorescent dye, which you mix with the sputum, and you take an image with a cell phone camera and you transfer that image to the cloud, and they have a program there which actually tells you whether this person has TB. So again, the sophistication is more in the software that they have. The model is built into the software, implemented in the form of a software. So cost is reduced, and at least I've read that the results are much better than what you get in a conventional assessment. So smartphone technology and fluorescent dyeing for frugal diagnosis of TB. In fact, the smartphone has been used for many applications now. There are many such applications which have been made possible thanks to mobile phoning. Again, Africa. Africa is just interesting, the numerous uses that they have put the mobile phone to, and we all take mobile banking for granted, but it all started with Africa. Thanks to them, I think because of the weaker infrastructure, the mobile phone was used to its maximum utility, and banking has been made possible thanks to that. And M-Pesa is one of the firms that has made this possible, and the model has been used many places. Again, African ingenuity for predicting, giving a weather forecast for storms, which is very important for, it's important for everybody, and especially for people who are dependent on it, whose business is dependent on it, like farmers. And we take it for granted when our countries use Doppler radar, okay, which is kind of very expensive. And some of these countries couldn't afford that, and they came up with this idea of measuring the lightning happening in an area, using that as a proxy to predict the storm, the intensity of the storm, in which direction it might go. And the brilliant thing about this is the model and the software was developed at University of Maryland, College Park in the US. There were 2 researchers who worked on it, and they had this thing ready, but there were no applications available. And then they realized that we have a case here where we can try it. Now this has become a very popular tool to kind of an alternative, to forecast storms. Okay, so and it gives results many times better than what you get with a Doppler radar. And they have actually opened a separate company for this. It is not just Africa; this is also marketed to other places around the world. Help from animals and birds. These are all out of the box thinking. Animals and birds go so many places. You can strap sensors to them, okay, and use that big data, to combine all of this to know the local climate variation in a place, and probably get also other data out of it. India space scientists, right? So this is a very good example of an advanced frugal case, because when we got independence, I'm glad that our leaders thought about, kind of getting serious about space. It has got a lot of applications, and we were cash strapped to begin with, but thanks to a brilliant scientist, they found a way to kind of work around that and make a lot of the space applications we have now possible. The whole thing started in a church, from what I've read about India's space program. Dr. Abdul Kalam and others, even before him, very instrumental in setting this up. And here is a nose cone of a sounding rocket being taken on a cycle, okay, for assembly. Of course, the Mangalyaan that India launched. And the interesting thing is this is 74 million, which is less than setting up a cricket team in the Indian Premium League. Okay, so, but the service is very good. I mean, if you can take this thing up to Mars and it does its job, right? But at such a low cost, it's just amazing. Relatively low cost. Okay, so again, when you say advanced frugal, the cost is relative here in that family. One needs to keep track of that. Astronomy can be cheap also. I think the square kilometer array in Africa, I think they have used dishes, right? Like which were used for probably mobile phony and television and whatnot. These dishes were retrofitted for radio telescopy and put in an array to be used for square kilometer array for radio telescopy applications. This is very interesting. It's called the SALT telescope, again set up in Africa. And this is an 11-meter telescope. It's a fraction of the cost of what you would typically develop, maybe in Europe and other places. And this is again developed for radio telescopy. And this is the way this is built. It has frugality kind of right from its basic conception. They chose a height where you might have some noise pollution, but because you're doing radio telescopy, you can take care, you can manage with that, not a problem. They also went for a spherical mirror. Okay, typically you use a paraboloid mirror, but here they use a spherical mirror. So by having a spherical mirror, you have some errors that are built into your signal. So they had a nice spherical aberration corrector coupled with that to filter the signal out. All this was done at low cost. Okay, it works very nice. And if you look at it, the mirror itself is built from numerous smaller hexagonal units. Typically for a telescope, you want to build the whole thing in one go. You grind this thing. It's a very expensive process, and here what they think, because cash was kind of a limitation, you make these hexagonal pieces of the mirror in different parts of this world, and they were all assembled on site, okay, to make this spherical mirror. And the entire telescope, it has very limited movement, what we call degrees of freedom. So it has got just one where it moves around the vertical axis, but that is enough to get the signal that it needs. And other than that, I think there are other features into it which are built to kind of give a simple model, but which does the job very well. built on a shoestring, about 30 million, built at a height of 1800 meters, not the best location for crisp images, but compensate with accurate spectroscopy, applications, and then spherical mirror that I talked about, and also, built of smaller units. Also, cube satellites. I don't know how many have read about this, but the satellite business, which is very important now, right, from entertainment to all kinds of other applications, and these are now also getting reduced in size. So we have something called these cube satellites. Satellites in the form, maybe the size of a shoebox, and these are just deployed in, kind of swarms to help you, with your application, low cost. And one good thing about smaller satellites, because you have to launch these things, you need smaller rockets. It's a big business, but now you need smaller rockets, so the expenditure is reduced. And this technology is getting better and better over time. I think the whole movement started about a decade ago. It is quite matured now. In fact, many countries, even universities, are experimenting with the cube satellites with their students to deploy them in space. And here, you get a feel for the size that you see here. I think you have NASA's Landsat 8, SkySat, then you have the Dove, right, which is a smaller CubeSat. And it's, roughly, you can see the reduction in the cost going into the size, okay? Just the satellite itself, and also the surrounding structure that you need to launch these things. I think that's a facility that is shown in the inset. Again, one more, cheaper CubeSats that are set in swarms for a given application. This is something that happened very interesting application with Professor Graves at University of California, Berkeley in 2014. It's one of the few thesis dissertations I've seen, PhD in chemistry, where they have developed a frugal plasma technology to generate plasma, but they call it frugal. Okay. Again, same thing, low cost. The quality is good and resources that have gone into it are less. Okay, this is kind of a sophisticated example which has been formally acknowledged in a thesis, and that too in the pure sciences. And this is again, from MIT, wherein low-cost individuals in a precision swarm. So you have, instead of using these robotic applications, using something big, you can have swarms of simple robots which can do the job very well for you. And here there's an interesting concept coming from complex systems and complex network theory. All of us have seen ants. When you have like multitudes of ants, you don't know what they might do. Okay, they might build an anthill, or they might attend to some other chore. You cannot predict that. That's called a complex network. So you have a big network of simple agents with simple interaction rules, but the emergent behavior coming out of it cannot be predicted. Okay, but this can lead to a lot of nice frugal applications. Okay, low cost, quality, you can engineer them so that they do in a way what you want. And the internet is a very good example. I'm not calling the internet currently an advanced frugal innovation, but it's an example of a complex system. So we take the internet for granted, but it's very difficult to subvert an internet, okay, the network that we have now. You can take some things off, but it will still continue functioning, which is a good example of a complex system, which can be used to advantage to generate advanced frugal products. But tomorrow I will be giving an example to the engineers on using a complex systems approach to building frugal products. And cheaper particle collider, this is interesting, at least I found it very interesting. So the Large Hadron Collider in Europe, right? You have a 27 kilometer long diameter structure, and all the things that go into it just to have, beams that can go at very high speeds, at least a fraction of the speed of light, so that you can make them smash into each other, and the particles, elementary particles coming out of it, are like the subject of a lot of research. Okay, that is what is supposed to help us with the standard model of physics, your Higgs boson. All these things have been possible thanks to that. So particle physics experiments are very important. They are very basic. It might not help you directly with an application, but it affects a lot of things that we do around us. And till today, right, a lot of these things have been done with, like I told you, 27 to 100 kilometer long structures in the form of a ring to kind of gradually accelerate this beam. And sometime back, I think about more than a decade, a technology was figured out where you can make these things on a tabletop, 21 centimeters, from 27 kilometers to like about 21 centimeters to get good acceleration. Plasma afterburner, just 30 centimeters long, accelerates electrons 100 times faster than existing ones. And this has now been adopted by CERN. They have a program called Awake, wherein they're using this plasma technology to develop tabletop, products, tabletop colliders. I think it's a good example of an advanced frugal product. The cost is really drastically reduced. Quality is good. It's a simple design, so you're saving a lot on resources going into it. Tabletop X-rays, again from the same family. And I think the last example that I'm going to show before I end today's talk is a 3D printed, a bus station made of cement. And it is not just products, right? In engineering, there are a lot of other things that are happening which can make your product frugal in different ways. So manufacturing is a very important activity. So anything which can reduce the waste and hence reduce the cost and also maybe reduce attendant emissions should be used. And 3D printing has a lot of applications from a frugal point of view. Of course, there are a lot of applications in general, but from a frugal point of view, there are many applications coming out of it, wherein you can make these products with lesser waste, good quality, and you can keep the cost low. And I think this was developed in the United Arab Emirates. Okay. And I think that's my last slide, gentlemen. And the question and answers, I think we can have it later, or I can even answer now. And this is just a glimpse of IIT Madras campus. It's a nice campus, a nice wildlife, and it's one of the most beautiful campuses in India. I invite all of you to come to my campus, and you can, I'm sure you'll like it. It's a joggers and cyclists paradise. Very nice. Thank you so much.